Okay, thank you, Andy, for your introduction, and I also thank for the opportunity to have again a speech here on the CEM conference, which I follow up and participate since several years. As introduced, I talk about sorbent trap monitoring systems for Mercury. Andy also mentioned that at the beginning of this session that in Working Group 8, we worked on a technical specification to standardize this kind of method, which is already used in the United States in several years. If we look on the legal requirements in the European Union, was also mentioned already before, there are new BREF documents, one for the large combustion plants and the other for waste incinerations, which request now continuous mercury emission monitoring. So for the European Union region, that's something new. In Germany, we do this quite longer, according to our 13 and 17 BImSchV, which are our national regulations. In both documents is also mentioned the use of sorbent trap monitoring as one possibility for continuous mercury monitoring, where if specific requirements are fulfilled. In the United States, this kind of sampling or monitoring solution is already used in several years in coal and lignite-fired power plants and also in cement kilns. So also there exists already quite a lot of experience with such kind of monitoring method. And as mentioned, we published the CENTS 17286 here in Europe as a technical specification to standardize this method also here in Europe. Topics of interest there by developing such a new method and also by introducing it are comparison to the standard reference method and also to Mercury Hg-CEMs. And one question is also the suitable temperature range of this method. If you talk to trap manufacturers, you get different information for that. Some telling you, the maximum temperature is like 180 degrees for long-term sampling, maximum 200, 210 degrees for short-term of several hours. So it was quite interesting for us to know what is really possible to do with this kind of method. If we look on the principle, on the left side, you see the copy of the sketch of the CENTS 17286. And on the right side, you see how such a system can look like in a complete and real design. So what is important here, we have a heated sampling probe, and in the top or in the entrance of this heated sampling probe are installed two of these adsorption traps. That they requested two traps is a quality assurance requirement of the standard. And one requirement there is that the result of the mercury content in the two traps, the relative deviation between the two traps should be less than 10%. So that's one quality assurance requirement. Additionally, what is very interesting, that the traps are the first element the flue gas is entering. So it's an extractive sampling, like always by sampling. But after this, the mercury is trapped in the sorbent traps. So after that, we don't need to take care of any cold spot or heated sampling line. So that's one of the big advantages of this method, that the first element is the one which is the important element. Because the extraction has to do under volume proportional conditions, we need to know the volume flow in the stack so we can get signals from the installed flow meter. But we also can measure optionally by a pitot tube the flue gas velocity and with a temperature sensor. After the probe, the flue gas is pumped to the cabinet. Here we can stop the sampling, and all the sampling process is controlled by a PC controller. And here in the first step, the gas is tried by cooling down to 5 degrees Celsius, and the volume proportional flow is controlled by a thermal mass flow controller. And sure, we need a vacuum pump for the extraction of the flue gas. I will talk also about a project. The goal was the modernization of a municipal waste incinerator. So this should be modernized. And in preparation for this modernization, there were done different measurements on the raw gas, so before flue gas cleaning and after, to see what are the good solutions, and with that to confirm the flue gas cleaning and to maintain this after the modernization. The exhaust gas cleaning here consists of a lime and activated carbon injection, followed by a fabric filter, a DeNOx SCR, and ammonia injection. So for this tests, there were installed different analyzers upstream, so before the flue gas cleaning. So for the Mercury, we used our model SM4 in the raw gas. Additionally, there were installed several CEMs in the clean gas, so in the stack. Also Mercury CEMs system from us, together with an Hg-CEMs system, which is a storm trap monitoring system, how described before. That was to monitor the efficiency of the flue gas cleaning. Another topic was here also the validation of the monitoring systems by comparison measurement to the standard reference method, so means EN 13211. The analysis of the storm traps of the Hg-CEMs were done by two laboratories. In this case, it was MPT and SGS. There was mixed different ways to generate different levels of mercury, so that we could see the functionality also there, not only on a, let's say, fixed mercury concentration. One advantage we had by this test was the fact that the flue gas temperature here is around 200 degrees Celsius and partly a little bit higher. So this was for us a method or possibility to validate the storm trap method also for such high flue gas temperatures. So if we look first on the results of the short-term sampling, we can say that all quality assurance requirements of NTS 17286 were met for the short-term sampling, also for these high temperatures, which was quite good. We only had at the beginning here quite big differences between the Mercury CEMs and the storm trap system, the Hg-CEMs, and the two laboratories which have done the standard reference method sampling. But because the results of the Mercury CEMs and the Hg-CEMs were quite nearby, we expected that there was some contamination, probably of the probe of the standard reference method. This was also confirmed by the later short-term samplings, as you could see, which were done several months later, that here we had quite good results between all the different methods. But in any way, confirming the suitability of the storm trap method by 200 degrees Celsius. If we look on the comparison measurements for the long-term sampling, there were, as I said already before, mixed different ways to have different levels of mercury concentration. So it was in the range between 2 up to 8 microgram per cubic meter. We can say first also that for the storm trap method with the Hg-CEMs, all quality assurance requirements of the NTS 17286 were met. So this means also for long-term sampling, we could confirm here the suitability of this method by such high flue gas temperatures. And we also could see a quite good correlation between the installed Mercury CEMs and the Hg-CEMs for these different sampling periods, which were between 10 to 12 days, and the different mercury concentrations. Then I come back to the legal requirements. So we have this new waste incineration BREF, which leads to consequences. There are mentioned continuous mercury monitoring requirements, and they are listed so-called annual emission limit values in the range of 5 to 20 microgram per cubic meter. So quite lower as it was up to now used in different countries. And as an example, in the proposal for a new 17 BImSchV in Germany, which is, let's say, our regulation for waste incineration, there's mentioned a daily emission limit value of 10 microgram per cubic meter. So we see the requests for emission limit values will go down. So for such daily ELVs are needed new Mercury CEMs, which can follow such low concentrations. And as it was mentioned already before, also in coal-fired power plants, we have even lower requests, like 1, 2, partly below 5 microgram per cubic meter. So there are needed a new generation of Mercury CEMs to measure such low concentration with high accuracy. Additionally, in municipal waste incinerators, the waste is not, it's different, and it's not, let's say, very homogeneous. And with that, we have variations of mercury concentrations, as it was also shown in the presentation before. So it's not the same like in coal-fired power plants where we have relatively stable mercury emissions. So to assure then on the clean side, so in the stack, stable low mercury concentrations, it is really recommendable to have upstream mercury monitors which recognize possible mercury peaks very fast, so that there is still the possibility to react on it, for example, by increasing the amount of activated carbon injection. The capability to follow such high peaks surely also needs mercury analyzers or Mercury CEMs, which are able to follow very dynamic such peaks. And this was also checked during the tests we have done by our project. So you can see here the blue line, which is the raw gas, or which are the raw gas values before the flue gas cleaning. For that, it's valid the left scale, which is going up to 800 microgram per cubic meter. And the orange line is related to the mercury concentrations in the stack. So for that is valid the right scale, which is going up to 60 microgram per cubic meter. So by the peak one, what we can see is, or at first before the peak one, that peaks in the raw gas, the first two, which are not very high, had no really influence on the clean gas side, so in the stack. But then the really high peak, the peak one, also generated a high peak on the clean gas side. But both were following quite dynamic. Then after that, on the clean gas side, we could see that the concentrations were not going down completely anymore. So that by another peak, what is here called as peak 2, even if on the raw gas side there was not a really high mercury concentration, we had already a peak in the clean gas side. So, and if we look now on the possible new emission limit value in Germany of 10 microgram per cubic meter, we will see that in such a case, the operator could get problems that these emission limit values will be exceeded. So this means we need new Mercury CEMs. So I introduce you here the functional principle of our new Mercury CEMs SM5. So in the top left, when the gas is entering from the heated flue gas sampling probe and the flue gas line, we have a thermocatalytic reactor. So we heat up to 950 degrees to convert all the ionic mercury into elemental mercury. After that, we have a acidic compound removal. So we have only a thermal conversion of the ionic mercury, which means we don't need any catalytic material and so on, which could be saturated. After our converter, we have a gas cooler to try the gas, and the analysis is done with cold vapor atomic adsorption spectroscopy, for which we have experience for around 25 years for the use of that. And with that, we could reach a very accurate results in the low concentration range, though this system was certified for the smallest range of 0 to 5 microgram per cubic meter. So it's therefore quite suitable to measure accurate such low concentrations like it will be needed in the future. Come to the conclusion. It was confirmed that the Sorption trap method is suitable for high temperatures of around 200 degrees Celsius, which is quite important for also our standardization work here in Germany, or in Europe, sorry. And this could be confirmed for short-term, but also for long-term sampling. So also for the continuous monitoring, how it is requested in the new BREF documents. The results have shown quite good correlation between the Sorption trap monitoring system AMESA-M and the installed Mercury CEMs in the clean gas. The raw gas and the clean gas Mercury CEMs followed very dynamic mercury peaks, whereby after the saturation of the plant, it could be detected a delayed reaction on the emission side, thus demonstrating the necessity to have such raw gas Mercury CEMs to be able to react fast on possible peaks specific in waste incinerators. And with the new SM5 Mercury CEMs, we could demonstrate also by the type approval that it's possible to measure very accurate mercury concentrations in the range of less than 5 microgram. So then I thank you for your attention, and visit our booth here on the CEMS conference or our webpage And I welcome questions later in the question and answer session. Thank you.